Year 6 Maths Revision, Mixed Calculations and Topics, Spring 1, Part 8. There are 10 questions. For each number, you choose either A or B or do both. Pause the video while you work it out. When you are finished, press play and I will talk through the method and give the answers. What fraction is shaded for 1A and 1B? Press pause. Okay, so first off, before we work out how much is shaded, we need to know how many parts there are. So on 1A, there is 1, 2, 3, 4, 5. There are 6 in a row and 1, 2, 3, 4. So we know there are 24 parts altogether because I just did 6 times 4 rather than counting every single square. I'm now going to tick the shaded parts. 1, 2, 3, 4, 5. 5 24ths are shaded. I cannot simplify that any further because 5 24ths, the common factor of the highest common factor of 5 and 24 is 1. Let's look at 1B. There is 1, 2, 3 rows and 1, 2, 3, 4, 5 in a row. So it's 3 times 5, which is 15. And there are 1, 2, 3, 4, 5 shaded. So 5 15s can be simplified further because we can divide 5 and 15 both by 5. Their highest common factor is 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So in its simplest form, it's 1/3, but if you got 5 15s, well done. Let's do the same for 2A and 2B. Okay, first off for 2A, there is 1, 2, 3, 4 rows and 1, 2, 3, 4. In each row there's 4, so 4 times 4 is 16. Let's count how many are shaded. 1, 2, 3, 4, 5. 5 16ths. We can't simplify 5 16ths any further because the highest common factor is 1 of both 5 and 16. Let's see how many pieces there are, how many equal parts there are for 2B. 1, 2, 3, there's 4 in a row and there are 1, 2, 3, 4, 5, 6. So 6 times 4 is 24. How many shaded? 1, 2, 3, 4, 5, 6, 7. 7 24ths. That cannot be simplified any further as the highest common factor of 7 and 24 is 1. Okay, we have 2 sets of subtractions with fractions. Please press pause and then we'll do it together. Okay, 3A, 1/2 take away 2/3. We can't do this at the moment because the denominators are different. So we're going to have to write them out again and find a common denominator. So let's write our 2's out. 2, 4, 6, 8, 10. And let's write out our 3's. 3, 6. Now I can stop there because I've noticed 6 is going to be the new denominator. So if I write it there, now what have I done to 2? I times it by 3, so I do the same to the 1. Right, 1/2, well we can clearly see 1/2 and 3/6 are both equivalent. And what have I done to this 3? I've times it by 2, so I do the same to the top number, and that's going to be a 4. Now, what you will find here is we actually can't do this particular subtraction, and that's because this fraction is bigger than the other. And I can show you that if I have a rectangle and if I show you half, which is what 3/6 is, and then if I show you another rectangle and I split that up into thirds, you can see 2/3 is greater than a half. So we do not have enough to be able to subtract 4/6 from 3/6. So if you work that one out, well done. Okay, 3B, we have a mixed number, take away a fraction. So what we're going to do, we're going to convert the mixed number into an improper fraction. So we do 1 times 5, which is 5 plus 2, which is 7 fifths. Okay, so we did 1 times 5 is 5 plus 2 is 7. Subtract 3 tenths. So that can be like that. Now, we need to make sure they have the same denominator. At the moment, we cannot do it because we have a 5 and a 10. So 5, 10, and look, I've noticed straight away that I can change the 5 into a 10 because 10 is a multiple of 5. So I'm going to keep the 10 the same, 3 tenths, and I'm going to change the 5 to a 10. I've doubled it, so I double the top number. So it's 14 tenths. I've just noticed I've made a mistake there. That needs to stay the same at 10. So the denominator is going to be 10. 14 take away 3 is 11. So my answer is 11 tenths. If I write that as a mixed number, it will be 1 whole and 1 tenth. Next, you have to multiply some decimals by either 10, 100 and 1,000. Please do both sides of those. Use your place value headings. Press pause and then we'll do it together. Okay, 3.5 times 100. So I've got my ones column, my decimal place, and I've got my tenths column. I'm also going to add in my tens and hundredths column. So I'm going to write underneath here 3.5. I'm multiplying 3.5 by 100. That means the digits move 2 places left. So the 3 is because there are 2 zeros, so that's 2 places, and we're multiplying, so we're going left because the number's getting greater. The 3 goes here, and then it moves again. The 5 follows it. We don't need the decimal place anymore, but we do need a 0 to say that there is nothing in the ones column. So 3.5 times 100 is 350. Let's do 2.32 times 10. I'm leaving my headings there. Let me get that. 2.32. And look, I'm using the hundredths column. Right, we're timesing by 10, so the digits move 1 place this time because there's 1 0 and we're multiplying, so they go left. The digits move left. So the 2 is going to move 1 place. The 3 will follow. The 2 will follow. And if you notice, we still have a digit in the decimal column. So we need a decimal place. So it's 23.2. 2.32 times 10 is 23.2. Okay. Now, over on this side, we're multiplying by 1,000 for both of those. We're going to need a ones column, I can see that, and we're going to need a tenths column with a decimal place. I'm going to put a tens column, a hundreds column, and a thousands column. Right, 7.2. When we multiply, obviously we're going to be moving left because we're getting bigger. And there are 3 zeros, so we move 3 places. So the 7 goes 1, 2, 3, like that. The 2 is going to follow. And we've now got 2 empty spaces, the tens and the ones column. So I need to put a 0 here and a 0 here. So 7.2 is 7 times 1,000 is 7,200. Okay, the next one. Let's rub that out. Is 5.8 times 1,000. Now, it's very similar to what just happened there because we've got a ones and a digit in the tenths column again. So we're timesing by 1,000, so 3 places, 1, 2, 3, 5 goes here, 8 follows. We have a 0 in both of those, so it's 5,800. All right, I have got here two shapes, two 3D shapes. I'd like you to write the name, and I'd like you to write the number of vertices. Press pause and we'll do it together. Okay, this is a square-based pyramid. I'm going to write that at the bottom because I don't have enough space. So you should have written square-based. Pyramid is spelt like that. Now, vertices are the pointy bits. Now, there's one on the top. It's a square on the base. So we know that a square has 4 corners. Now, you can only see 3. One of them, if I draw that on, one of the other vertices is there. So this has 5 vertices. Over on the other side, we have a triangular prism. Check you've spelt those words right. Very common spelling mistakes. Now the vertices, well, there's 1, 2, 3, and there's going to be 3 on the other side. We can only see 1 in this picture, but if I draw on what it would look like if it was see-through, so there's 1, 2, 3, 4, 5, 6 vertices. Okay, for this one you have a whole number, subtract a decimal. So have a go at doing that and then unpause the video. So we're going to do 5 subtract 2.34. I need to put on here a decimal place and I need to add 2 zeros, and I put a decimal place in my answer box. 0 subtract 4, you can't do it. We can't go next door. So we're going to make that a 4. This becomes 10. Across that becomes 9, 10. 10 subtract 4 is 6. 9 subtract 3 is 6. And 4 subtract 2 is 2. 2.66. And over on this side, 7 subtract 1.56. Put a decimal point here. And I need to add a 0 there. So we are going to have to go all the way to the 7, make that into a 6, 10, 9, 10. 10 subtract 6 is 4. 9 subtract 5 is 4. And 6 subtract 1 is 5. 5.44. Okay, Roman numerals, but today you've got some additions and some subtractions. And let's see if you can work that out. Press pause and then we'll do it together. Oh, by the way, see if you can give your answer in Roman numerals. So, x is 10 and VI is 6. 5 add 1 is 6. So the answer is 16, and in Roman numerals that would be XVI. Okay, C is 100 and it's times IV. IV is 4 because the V is 5 and we take away the 1. So it's 100 times 4. Now 100 times 4 is 400, and in Roman numerals, if I write that underneath, D is 500 and you take away 100, which is C. So it's CD. 400 is CD. M is 1,000. And we're taking away CD, which we've just discovered is 400. And 1,000 take away 400 is 600. So if I write that at the top, we're going to put a D, which is 500, and a C, which is 100, which makes 600. XL is 50 because is 40. L is 50, and you're taking away this 10, and that's 40. Okay? 40 times IV. IV is 4. So it's 40 times 4. Now 40 times 4 is 160. And 160 in Roman numerals would be C for 100, L for 50, and then add the 10, 160. Okay, I would like you to work out the perimeter and the area of both of those. So press pause and then we'll do it together. Okay, so for the square, there are 4 sides and each side is 3 centimetres. So we do 3 times 4, which is 12 centimetres. Now, to find area, you times the length by the width. So it's 3 times 3, which is 9 centimetres square. When we use area, we always put a little 2, which means area. For the rectangle, the perimeter, so I'm going to need a bit of extra space to do this. So I'm going to move my let's see if I can do it down here. So I've got 7.2, so this side's going to be 7.2, and that side is 4. So 7.2 times 2, 2 times 2 is 4, 2 times 7 is 14. So those two sides equal 14.4. And these two sides are 4 and 4. Now 4 and 4 is 8, so it's 14.4 add 8. Notice how when I'm adding, I'm lining up my ones. So 4, 8, 9, 10, 11, 12. So 22.4. Right, so that's the perimeter, 22.4. I now need to find the area. To find the area, we multiply the length by the width. So we're doing 4 times 7.2. And for this one, I am going to move my rectangle because I'm running out of space. So we're doing 4 times 7.2. So we put our 7.2 here, our 4. Remember, when we multiply, we don't have to line up like for like. So we do, but we do need a decimal place in the answer box. 2 times 4 is 8. And 7 times 4 is 28. So the area is 28.8 centimetres square. Right, here we have a regular pentagon. That means all the sides are the same. And a regular decagon. That means all the sides are the same. A pentagon has 5 sides. So there are 5 sides and they're all equal. A decagon has 10 sides. So there are 10 sides and they're all equal. If the perimeter of this pentagon is 35, what would one side be? And if the perimeter of this one is 50, what would one side be? Press pause and then we'll do it together. Okay, for the pentagon, we have 5 equal sides. So we do 35 divided by 5, which is 7. So one side is 7 centimetres. The decagon has 10 equal sides. So we do 50 divided by 10, which equals 5 metres on this side. For the last one, please write the decimal equivalent for each fraction. Press pause and then we'll do it together. Half, 0.5. 3/4, 0.75. 1/4, 0.25. 1/100, 0.01. 1/5, 0.2. 3/10, 0.3. 1/8, 0.125. So that is our calculations for today. If you got one wrong, check it, go over it again. If you still don't understand and you think I've made a mistake, let me know and I will see you